Start recording. Okay, so yeah, where do we leave off?
I got this Squircle code in
Oh,
here.
the
I don't know if
Squircle. That's
I don't
right.
know if we're supposed to still have that or not.
Well, yeah. So if you go back into program.cs, we can, we're done with the shader test. So let's switch that back to the poorly named InGUI,
Oh yeah.
the line business. We haven't looked at this one for a while. So for the people watching on YouTube, this is going to be a short one. We're just going to finish off our line rendering. So yeah, we can draw our lines and zoom around and zoom in and check out that pixely goodness on the edges.
Yeah.
So we're going to fix that up. So let us make a new effect, and let's call it like a text file. Let's call it line effect.fx. And then we have to go into the properties sheet for that thing and change the build action to build shader, compile shader. Okay. Now I'm going to cheat slightly and have that off to the side. Okay, so let's start with our example effect. So this is what we had before. So just grab example effect and just copy that into our line
Yeah, that's
effect.
the thing. I think I squircled it, the example effect.
Well, that's all right. So see where you have, okay. In fact,
Hold on a sec. Maybe I can,
oh, you can just
yeah, I don't want to do that.
just copy the code that you see on my screen. That should be simple enough.
Okay.
If I bring it back. So yeah, that one's fine.
So all that stuff's the same. Float
one's
length
fine.
square is the same. Steps the same. I'm basically just killing off Squircle and doing
Yeah.
circle times color.
Yeah,
Okay.
Squircle is just for fun. We don't need that. So this is the example effect. In any case, so save that off for later. But we actually want to make a new line effect. So you've got line effect. Okay, yeah. So we're in position for that. Okay. So let's see. First of all, thinking about what we're doing. We're not using the texture sampler, so we can actually get rid of that. We don't really need it in the example either anymore, but so we'll nuke that, and we've got our pixel shader function. So we're going to write a vertex shader now. So this we'll write the pass for it. So it's vertex shader equals compile for vertex shader 2.0. That simple as that.
Okay. And this is just declaring those shader model, vertex shader model.
Yes. And I think what we're doing is just a-okay in Vertex Shader version 2. I noticed that FNA and XNA, well, FNA is a lot looser with what you can do in different versions rather than XNA, which is like quite strict about it. So let's see. We have our pixel shader function. That's fine. That's doing exactly what we want. Now we just need a bog standard vertex shader function. So let's see. We want vertex shader function. Now we want a return value. We're going to return some custom things. So some vertex shader output. And we want some custom input. So input. So let's let's define what these are going to be. So, and this should be like super familiar because we actually went over this all in a couple of lessons ago. Struct. So we've got the input is a struct, and we've got the output is a struct. And so the question is obviously, what do we want? What do we want to have going in and coming out of our vertex shader? And
right.
so I mean, let's have a look actually at the code, because we've actually got code for this in this one. So we're making a vertex buffer. We have vertex position color is our declaration. Is that correct? No, that's not correct. That's because that's our, we have like a triangle sitting on in the middle of the screen. Oh, I can't build at the moment because the shaders doesn't work. But
yeah,
you remember, everyone remembers the triangle. But we had another vertex buffer for the thing, and that was set up in vector-based lines, load line drawing content, and we had dynamic vertex buffer, and we had vertex position color texture. And we can go, or we can F12 on that vertex declaration. So, yep. So in private static constructor, you will find the layout for this vertex format. So we have position 0. So you'll recall that these are made up of right, what is the offset in bytes of this particular piece of data? What kind of data is it? It's a three element vector. And then what's its usage? Its usage is position, and its usage index is 0. So if we go back to our shader now, that one, we have, we can now do like a float. We could do a float 3, but it will automatically expand out if we do a float 4. Position. Position 0. And so this is the name. So this could be, foo or baz,
yeah,
or position. But this one here, this is like part of the language, and it says, give me the vertex element usage position index 0. So if that was a 1, I could get position 1 and so on. So we have position 0, and we also have, if we look at this, we have color 0 and texture coordinate 0. So this is a simple matter of color 0, and float 2.
We're kind of just having to do what Renee has already laid out for us, right? Like we're getting these. I mean, I guess we're the ones declaring this, but this has been declared. This is declared by FNA. Like, this is the data format that we have. This is the structure.
Yes. So this is the way the vertex elements are laid out in memory as they're sent to the GPU.
Right.
So as we fill out this vertex buffer here, this is the layout that we're using. The GPU loads those, and every time we run our vertex shader function, we take this input. Mm-hmm. The layout of this structure does not have to match, because the way these are passed is through these usage things. So like I could move color up here and it wouldn't matter. In fact, I could actually, yeah. I'm not sure.
Well, the indexing information is coming from those special variables.
Pretty much, yeah. So it's loaded into a particular register, conceptually at least. I'm not sure how it works these days.
Okay.
0. So
I'm just interested in like how you're putting position 0, color 0, but color is actually offset by 12. But this is color 0, texture coordinate 0, and those are what you're looking at here. So
exactly
the 12 and the 16 don't matter.
Yeah, that's that's the buffer format, not the format for the function in the shader.
Okay, that makes sense now.
Yeah. So that's the vertex declaration is like how that transformation works. Basically, it's like here's the buffer position, and this also gives you the size of the element in the buffer. And then on the flip side, it's like, okay, now the output is like that, and that's the output, and that's the output. So, input, output.
Right.
Now, the output of our vertex shader is going to get passed into our pixel shader function. And it works in much the same way. I could put really whatever I want in the output. It's going to get passed into the pixel shader by, this color 0, texture coordinate 0. So I'm just going to grab all that and stick it in there because I actually want pretty much the same output as input, because I want a color, obviously, because we're getting a color 0, and I want a texture coordinate, so because we're getting a texture coordinate 0, and I also want a position, because this one is special because the GPU is going to use that position 0 to lay out the triangle that it's about to shade.
Okay.
So then it's simply a matter of coding up our function. So we want an output. So output. And so then we want to set these things. So first of all, output.color is the same as input.color. And then output.text chord equals input text chord. Now, of course, when the pixel shader goes, we get these texture coordinates. We get texture coordinates for the whole range, like from 0, 0 to 1, 1. You remember that. We get every single pixel in there. And so what happens is this is the output for that triangle. It will then, when it goes to rasterize that triangle, it will interpolate all those texture coordinates. And if we had like different colors in different corners, it would also interpolate the color for us as it rasterized the pixels. Does that make sense?
Barely, but yeah. I mean, I remember when we were messing with the colors to show that, it's basically sampling each one in the coordinate space. You're saying the same thing is going to happen here.
Actually, this is a really good thing. Let's finish this out. So for the time being, we'll just write output.position equals input.position. We'll have to fix that up in a sec. Return output, and at this point the shader should
nothing.
Yeah, pretty much. At this point, the shader should build. So let's give that a go. No, we illegal. Illegal character in shader file. What do you get?
Do we need missing semicolons or some silly thing? Probably
No.
not.
Okay, so this is a fun one. Encode as ANSI. Let's save it again. And then I got the same thing as you. So there's a bug in the DirectX shader compiler that does that. Okay, what have I done wrong? Struct. What? Haven't misspelled it or anything. Line 10. Oh, yeah. Missing semicolon.
I was right. I got a thing.
Nice. Yeah, that's like a holdover from like C and C++. They're like, you need semicolons everywhere.
It's weird because we don't have them for the functions because that makes sense.
Yeah, it's
sort of barely makes sense, but
it's a stupid holdover. So the reason I was bringing this up is so we can like zoom in on our happy little triangle over here. And so we've got 3 vertices. We can even look at the code for this. Where's it gone? We have vertex position color. We've got red, lime, and blue in the 3 corners. And so, we've got this blue one here, we've got the green one here, we've got the red one here. All the values in between are interpolating between those values. So, we get halfway between red and green here, we get halfway between red and blue here, and we get halfway between blue and green here. And obviously in the middle we get like halfway, well, sort of a mix of all three, and we get this gray sort of thing in the center. And so that's how the rasterization step takes like 3 vertices and turns it into several hundred pixels. So the same thing happens with the texture coordinates. So we are using textures for these. So if you recall, we passed in like 0, 0 over here, and like this is 1 on the x-axis and 0.5 on the y-axis here, and to figure out what pixel it draws, it interpolates between them. So it's like, give me the pixel that is like 0.45 on the x and like 0.01 on the y-axis, and it's like that amount into the that proportion into the texture, give me that pixel from the texture. So that's how it does the texture selection as well, as it interpolates those values. Does that make sense?
Right. Mm-hmm.
Yep. Okay. So now we are going back to here. So this is going to make us kind of sad. Let's see what happens when we do this, because we're going to get some bogus output if we just use this pixel shader. So let's try and use that pixel shader first. So coming back to this guy here, you recall we have this basic effect line effect in the code.
Yeah.
Let's switch that over to effect line effect, because we're going to get rid of basic effect now. And we'll get a couple of errors from that because we need to set it correctly. So let's find where we set it up. Okay, so down here. I was thinking, how do we load a thingy in this? I can flip over to the shader effect and be like, here's how we loaded the example effect. I'm just going to copy that text. So we want line effect, and we want to load it from effects line effect.fxb. Make sure we've got file. So we've just replaced all this with that. So
yeah, so I'm having a hard time finding you. I just need to find where I'm doing we're doing the new up of the line effect.
So this is in load line.
Oh yeah. Okay, right
content. Here. Yep, right there.
Yeah. For some reason it didn't give me any errors because I had a basic effect is a line effect.
No. Basic effect is an effect. It derives from effect.
Yeah, right. Yeah,
it's that
class.
So there. Yep.
I'm just wondering why I didn't get build. I didn't get. Oh, because you're doing the whole struct thing. I don't know. No, I don't know. I'm not getting errors for any of them.
Oh, okay, yeah.
I'm doing it with the.
That one's not going to be a problem. The reason I was having problems is, texture enabled is not a member of effect. It's a member of basic effect. So yeah, that's why you're not getting errors there. Exactly. But later on, these ones will cause errors for both of us.
Yeah.
So now these things, including the texture, is stuff that we don't have. So we can just get rid of all of that. Because there's basically different versions of basic effect that do, like we talked about, you can have the vertex colors on or off, and you can have the texture on or off, and you have the lighting on or off, and that will depend on what values you pass into the shader. Do you pass in a color? Do you pass in a texture coordinate? Do you pass in a normal? And so on, and some of that data you'll need for lighting or for texturing or for coloring, obviously. But we just have a single function that, and we know that it wants a color and it wants a texture coordinate, and that's it, and obviously a position. So that's good. Now we need to roll down here. And so these should be the only 3 errors remaining. And we don't have a world view projection, which brings us to our problem. So let's just comment these out for now and run it. And you'll find that all of our lines have gone missing.
Right.
And the
Which
reason
makes perfect sense because we're not viewing them by any means. Like
exactly. So we need to do the equivalent of this world view projection. Now, the world matrix is the identity matrix, so that does nothing. So I can get rid of that. And
right.
I think I talked about this at some point, and that is the view projection matrix. We want to multiply this through initially. So let's just say matrix view project equals, the view matrix times the projection matrix, which is going to be that.
Right. The orthographic off-center is the classic 2D view of 3D space, right?
Exactly. So this is creating a sort of a projection that's got, well, if you alt space, what is it? Control Shift space on these, you get the first value is what is the coordinate of the left of the screen? It's 0. What's the coordinate of the right of the screen? It's the width. What's the coordinate of the bottom of the screen? It's the height. And the coordinate of the top is 0. So you get this window that goes from 0, 0 in the top left corner to width, height in the bottom right corner.
Right.
And so
classic client window for Windows, right? Is that
exactly? And I mean, if you wanted a flipped window, you could flip those coordinates around. You could have 0. I want the 0 on the bottom and height at the top, which is sort of another common way of laying this thing out. Okay, so we've got the view projection matrix. We need to get it into our shader. So let's come back to our shader now, and just say we've got a float 4x4 view projection.
I don't think I assigned that yet in the code. I think I just made it.
Yeah. So
the projection.
Yep. So this float 4x4 is the same type as matrix, and we can now go into here and just be line effect dot parameters.
Oh right, yeah, that makes sense.
View projection, and so we're asking for that particular parameter in the shader, and we're going to set value view project. And in theory, this will at least run, but it's the same as before because we haven't modified our shader. So see if you can at least run at this point. Make sure everything works. So yeah, hasn't complained that this doesn't exist or anything. So we've typed all of that correctly. So all we need to do now is multiply our position by the view projection matrix, and hopefully we've done enough maths to understand what that means. So mul is a function here, and view projection. And so in theory now, oh, that looks promising, hey? And we can zoom into that, and oh, look how smooth that is. Super smooth. Whoops.
Where did how?
Yeah.
I don't recall the part where we wrote any math for the circle.
Oh, that's because we copied it out of our shader from before. So we've just taken the entire pixel shader function that we were doing in the shader test, and we've just used that same shader because if you recall, we wrote that so that it was exactly. It basically replaced the texture. So what we've really been doing is we've been replacing the vertex shader from basic effect. So the position, color, texture, basic effect vertex shader is basically that. And so we've just replaced the thing that would look up into the texture coordinates, look up the texture, and instead we've replaced it with the thing that generates our circle based on the texture coordinates. And so we get this nice thing with like these lovely thingy things.
They're lines.
They're lines. They're lovely lines. So I think we might call that for today. We could look at, yeah. I don't think we'll worry about anti-aliasing them, at least at the moment, because that's very different maths to what we're doing. What we might do, just because it's going to come in very handy, is we're going to make a little helper method. So let's just write a real quick helper method now. We've got finish lines. Just going to write a quick method, and that is what's the signature for this? Okay, yeah. Void circle, and that's going to be vector2 position, float, radius, and color. And this is just going to be, this is kind of stupid, like just dumb. And it's basically, rather than trying to set up the vertex thing and make sure we have the right number of indices and maybe even be able to fill it out, we're just going to make a line that has 0 size. So position, actually this is not going to work, I think. And this could be something.
Oh, I get it.
This could be something interesting to fix, because we're calling vector2.normalize, and that's going to complain heartily when this has got length of 0. So we're going to have to fix that up. But that's fine. I'm glad we're doing this now. Radius is going to be thickness. Is our thickness a thickness or a half thickness?
Probably. Or it's going to be halved in our line method. So probably.
I think we need to do that. And then, so if we do this, and then, why are you complaining? Can it convert float to?
Oh, it's an integer.
Oh.
That's all. Just.
Well, that doesn't need to be an integer. That's fine. I was like, let's change, because we will actually want this, because recall that we can zoom in and out. Yeah, zoom in and out on our lines. So we'll actually want.
Yeah, half stepping and all that. Yeah.
Yeah. So yeah, get rid of that castaway int. That's for sure. And so let's just make sure this will work. Let's find the thing that draws lines. Actually, let's, if partial line, we're drawing a line, let's draw a circle as well. So mouse world position, radius of say 50, and color dot, I don't know, pick a color. Bisque, don't know what that is.
Sounds like soup.
Yeah, okay, so if we run that, we get nothing. And I think the reason that we're getting nothing is
we're
because
normalizing it into
we're normalizing a thing that has length 0. So if you recall, do you remember what the well, I mean, we can look up what the normalize function does. Where's this run off to? Normalize. So we can actually F12 on this one and be like, right, we're taking the length here. So this formula should now look very familiar to you. And we're taking, so this is going to be 0 because we know the length is 0. We're taking 1 divided by 0, and as you know, we can't divide by 0, so this is going to be invalid, which is going to result in.
It's going to be it's going to result in not a number constant?
Yes, that's probably what's happened. So to solve that problem, we need to come up with a method that doesn't cause that. And I'm just gonna say we're just gonna bang this in here. Vector 2 safe normalize vector 2 b, and this is going to be very similar to that. So float length equals v dot length.
Oh, right. Yeah.
And then this is not optimal, but we're not doing this too much. If we were doing this a lot, maybe we might want to move the square root or something. Yeah, it's not really worth it. If length is less than float dot epsilon, perhaps, or we could just say if length equals. I'm always nervous about doing this because length equals 0. Just because length is less than. Yeah, if I was thinking harder about this, I'd go and look up what the floating point value could be, like, so that I get the length when it's like really, really, really tiny. But if it's too tiny, then I'm going to trigger this condition. But we definitely want it when length is equal to 0, and in that case, we want to return something just that is a unit 1 vector. Not 0. Not 1 unit x. Yeah. Else return b times. And so this is obviously what the normalize function was doing. But if we have no length, we still want it to spit out a vector of length exactly 1, because that means that all of the maths that we use, all the maths that we have that expects a length 1 vector is still going to work, like this case.
Right.
And so now, in theory, yeah, we have our bisque colored massive circle. How'd you go? Yeah, too easy. And so that's going to come in handy very soon. Well, in the next lesson, because we're going to want to start doing some collision-y sort of things with circles. And so having a method that's like, draw me a circle, is going to come in very handy. So that is, I think, everything we want to do today. I think, and I think that's sort of the end of our line drawing fun. So I mean, if you wanted to study this code and maybe clean it up, it's pretty clean at the moment, because like it's minimalistic, if you know what I mean. It's just some methods. So the only really thing that you could do is you could maybe like move that safe normalize off into, we've got our vector extensions thing. Yeah. So you could move it there, and all of these line methods, they depend, like line, finish vector lines, and load drawing content. You could bundle that into a class now, because it's like these all do the same thing, and maybe we want more than one of those. So and then so you'd want to like identify all of the data that uses. So it's like, okay, we've got this buffer, this effect, this constant, that other buffer, and this count. Just bundle all of that into a class, and then it's like, all right, we've got our line drawing class, and so we're ready to roll, and we can like reuse that. So yeah, that's really all you need to do for cleanup, and that's kind of that's kind of like how that's sort of an idealized way of making classes. It's like you don't really start with a class, you just write the code that does the thing you want, and once you've done and you know what it does and stuff, maybe then you bundle it off into a class when you're done with it.
Right.
And that just makes your code better. And so we've talked about that in the past. So let me find OBS, and we'll finish the recording. Thanks for watching, everyone.